Today I'll just code and show you show you how to use the constructors of hash set and linked hash set. Okay, we'll visit that and then you can see the constructors now of hash set in Java. Yeah. So you know the behavior of all the four constructors. Just I'm going to show you how to code them, because see here, there is something called as float load factor. Okay, so this is where it becomes important, very tricky. Okay, many people try with what? 0.7, 0.25, 0.5, and you get error. Reason is your basics. You're forgetting your basics. When it is saying float, you have to send what value? Single precision value. F you have to add. Yes or no? So let's see that. I'll go and code the test project. Hash set constructor demo. Let's see this hash set constructor demo. Yeah, this constructor, you know how it works. Till now we worked with this constructor only. What will this constructor do? Allocates memory for 16 elements, and the load factor is 0.75. Means 16 elements will be allocated. As soon as 12 elements in that collection fills, so automatically 16 more will be allocated. You know the behavior. Yes, let's see this. Now the other constructor is int initial capacity. So if you want to change the initial capacity, you can make it 8. So when you create the hash set object now, what will be the size? 8 elements. Means 8 buckets. Okay, again load factor is how much? 0.75 only. Means as soon as 75% of 8 fills. What is 75% of 8? 6. So there again 8 more will be allocated. Not 16, 8 more will be allocated. Then next, one more you got now. Okay, what is that? You want to specify the load factor and the capacity. Fine, you can do it. See this. 8 comma, I'll say 0.25 also I can say. Means as soon as 25% is filled, means when you add 2 elements, again it will increase. It's giving me error. Why? It is float. So always do not forget your basics. All this I have taught in basics. Understood now? So Java's programming is all about what now? Calling methods, sending arguments. You should know how to send the arguments, that's it. Automatically code will execute for you. Understood now? Yes, so you have to use the F here. Only means single precision. Or if you want, you can increase it to 0.5 also. That's also correct. Default is what? 7.5. And the load factor should be between what? 0 and 1 only. 0 point anything to 1.0. 0.0 to 1.0. Clear? So that's it about the constructor of hash set. So same constructors are there for what? You know this one, you know, no? You can send any collection. Array list or linked list you can send. Okay. Same constructor is there for what? Linked hash set also. A linked hash set is a sub-interface of this, subclass of this. Same constructors are there. Empty, collection, capacity and load factor. Means add that F. That's it. Clear now? So basics are very, very crucial here. Okay, so if you don't know how to use the float, here you will start struggling now. Yeah? Floating values. Okay, fine then. So in Java, always float should be written with what? F. You know the reasons now, single precision. Okay, so you can try this. Float F is equal to 4.5 is error. 4.5 F you have to write. That's how you have to write in Java. And this I have covered in basics when I was teaching you data types. Why and all I have covered it. Okay, so next we'll move to the next topic of collections now. Maps we'll visit. Clear? Yeah, this is map now. Okay, so now we'll move to maps. So this is also in the collection framework only. Okay, this is also in the, we have completed which one now? Set, sorry, which is that collection. Now we are moving to map. See, the super interface is what here? Map. Earlier the super interface was what? Collection. So both of them come under what? Collections framework only. Okay, fine. But what is a map? It is very clear here. So map stores values using key value pair, we say. Key value pair. That's how the map stores the value. Fine. So Java gives you tremendous support now. You can store only values or you can store key values also. So see, when Java was released, 1.0 version of Java was released, okay, what was happening, what had happened was, there was a class called as dictionary. What is the class name? Dictionary. So in the dictionary class, okay, it had two subclasses. Means dictionary had one subclass called as hash table. Notice the spelling here, hash table T small. Okay, don't get confused, because generally we have a convention. When we have two words, the second word will be caps, but here hash table is T small. Then again hash table has a subclass called as properties. So this was what happened in Java 1.0. Okay, so this is an abstract class. Dictionary is what? Abstract class. And these two, hash table is implementing those abstract methods, plus properties is also extending and adding some more extra methods. That's how they are designed. So actually earlier in 1.0 you have to use dictionary to work with key value pair. Okay, so in 1.2 means in 1.0 you know the problems now. What are the problems of 1.0? Less support, and one more is they were synchronized. So to give more support in 1.2, again they came up with the framework here. To give more support to key value pair, what did they do? They came up with one framework. So map interface was introduced. Earlier it was not there. This was introduced when now? 1.2 version of Java. It was introduced. And see, earlier this was the case. But later on what happened? They made hash table implement what? Map interface. It was re-engineered. So hash table means we need one standard way to work now. Otherwise this will have its own methods. Hash table will have its own methods. And hash map, linked hash map, TreeMap will have their own methods. So it would have been confusing and difficult for us to work. So they wanted to have a uniform way to work with all these classes. That's the reason they re-engineered. Okay, and what they did was they didn't remove the old methods. Till now also hash table extends what? Dictionary and implements map. Same way like vector, what it is doing. Okay, vector has old methods plus it is implementing list. So hash table what it is doing? It is extending dictionary plus it is implementing map interface. So actually if you see today, what is hash table doing? See, this is the case today. Dictionary is also there. Just for your information I am writing. Understood? And it is implementing map interface also. So it will support both the methods. Okay, fine. Now one more small change in the diagram, if you had written it earlier, is I have added one more class here called as properties. The first time when I had shown you these diagrams, properties was not there, it has been added now. So just modify your diagram. So this is the hierarchy. Now we have to study all these classes and interfaces. So let's study the legacy ones later. These are called as legacy. Dictionary, hash table, properties, they are legacy. First we'll study the new ones which are added in what? 1.2. Okay, 1.2 version of Java. So first I'll be going with what? TreeMap. Then I'll cover other things. Understood? Legacy we'll study later. So this was a brief introduction now. So map is used to store what now? Key value pair. And these set of things were added in what? 1.0. And just make on highlighting things here. 1.0. Here navigable map was added in 1.6 I think. Yeah. 1.6 it was added. Navigable map. These were all added in what? 1.2. All this was added in 1.2. Only this one is extra. 1.0, 1.2, 1.6. Clear now? Okay. Here also, if you want to see in this diagram, to have a brief idea. You got this previous diagram now? Dictionary in 1.0. Hash table 1.0. Properties 1.0. Understood? navigable map 1.6, and rest all came in 1.2 only. Yeah, this is how the versions were added, and that is why the information, and you don't have to by heart this, in the document you can find this when it was released and all that. Clear? Okay, shall I clear this now? If you want, I'll just show you the versions of what? Collection. Here, yes, this was in 1.2, most of them 1.2. Only this one, navigable set 1.6, priority queue 1.5, 1.5. Rest all whatever you see here is 1.2 only. Okay, and the vector, 1.0. This is the story. So in 1.0, these two were released. 1.2, many were released, but 1.5, 1.5, 1.6. Okay, we see most of the things. When I'm covering 1.5, I'll be covering all those things. Understood? So till now, right now what I'm covering is still 1.4. Then I'll cover what are the enhancements done in 1.5. Then I'll tell you what was done in 1.6 and 1.7. So we're going with the history like this. So we are seeing what excellent support we are getting for collections now, and why it is under constant revolution, because we have problems and Java goes on enhancing their libraries. Instead of you doing it by ourselves, they give a terrific support like this. So it's with experience they do it. They cannot design it overnight. Done? So you should understand how they prepare the libraries. So once you understand how they prepare the libraries, then we can use it. That's why this history is very mandatory. Okay, not from by-hearting point of view and all that, but from developers point of view, we should know how to use these libraries. Clear? So this is a story about map, and that same thing I have documented here. I have given you earlier. Priority queue 1.5, just now I wrote you, and navigable set, navigable map. Okay, they are all coming under 1.6. Some interfaces and classes are not listed there, but they are still added, DQ and all that. Listed. Fine. We'll see all that. Just when we go to 1.5, we'll see that. Straight away move to map now. So what is map? Map is used to store what? Key value pairs. That's it. Some more information. Map is also part of collections framework. A map is an object which stores key value pairs. You need a key and a value to store in a map. Now if you ask me what is a key, simple, both key and value are objects. Understood? When you see an example, you'll understand the concept here, and to prove this concept I'll be giving you what? Simple, an example. So given a key, you can find its value. The keys must be unique, but you can have duplicate values. Some maps allow null keys and null values, others cannot. Now leave this part, come to this main part now. Okay, so there are many different implementations of the map interface: TreeMap, hash map, linked hash map, hash table, properties. This you just now saw in the diagram, hierarchy. So I'll be going with the first one. You can study it in any order. The first thing what I'll be showing you is TreeMap. So let's straight away see an example better. So first I'll open the document for you. See, this map has some methods, map interface. These are the methods: clear, contains key. So obviously all these classes will be implementing what? These methods only. Yes or no? TreeMap, hash map, they are all implementing these methods. Map is an interface, do not forget that. Understood? These are the common methods which you will find in all the classes. Yes, straight away I will be moving to what now? One of the implementing class called as TreeMap. And this is the one. But in TreeMap, if you see the hierarchy here, one more is coming there. Sorted map, yes or no? And navigable map. Two more are there. See this hierarchy, don't forget. TreeMap is implementing navigable map. Navigable map is extending sorted map. Sorted map is extending map. So you get some methods from here, some methods from sorted map, some more methods from navigable map. So TreeMap today has some extra methods, but they come from where? Navigable map. Because in 1.4 they are not there, they were extra added in 1.6. We'll study those extra methods later. Right now I'm covering what was the support we are getting till 1.4. Understood? So this is how you have to study the library. Understood? Clear this? Yes, sir. So now this is and the same thing you can see in this document also. They are putting it like this. Say TreeMap. You can see here all implemented interfaces are what? Navigable map, sorted map. Yes, it's a class. TreeMap is extending abstract map is extending object. And here, yeah, these are the implementing interfaces. It's implementing map, navigable map, sorted map, serializable and clonable. So like this, the document clearly gives you the information about what is this class. So this Oracle people, alias I'm releasing all these documents for every class. They release the documents, every interface. Otherwise it will not be easy for us to use it. So I'll design on class. If I don't give you a document, how will you use it now? Can you go on seeing the code what I've written in my class? Huh? We work on abstraction. In Java, what we do? We work on abstraction. We just understand what that method is going to, what purpose. Means if I have a method, what is it going to do? Only that much I'm going to study. I'm not bothered about what is the implementation in that. So that's why whenever a class is prepared, they prepare documents like this and then they'll release it. Earlier Sun was doing now, but Sun has been taken over by Oracle. Oracle people will be doing it this now. So yes, sir. This is the story here. More information is there. Okay. Gradually with examples you'll understand the document. So in Java clearly understand. C, C++. What is not required? Oops. Nothing is required. What is required now? Common sense and English. Clear? You have common sense now? You have English knowledge now? 22 years you have studied English now? And you are very strong in English. Yes? So obviously you know Java then. What is so difficult in Java? Okay, let's see now. So these are all the methods. Okay, we have to study now. Yes, so now I'll come to TreeMap. Yes, in TreeMap, these many methods are there. Fine, one by one I'll start off now. First, what is key value pair? I'll introduce. Simple. TreeMap, map is equal to TreeMap, yes. Next what? Map.put. This is the key. What is the value? This is the value. So the key is an object. Value is also an object. Key is what type of an object here? Integer type of an object. Value is what type of an object? String type of an object. That's it. So you can store values in primary memory using key value pair. Okay. Now this key is what you are putting now into the tree map. We'll be using tree structure to store the keys. Now almost all if you know tree set now. Almost means if you know tree data structure, this becomes very easy for you. If you know the tree data structure and the behavior of what? Tree set, automatically you'll understand this. I'll just represent it with a diagram. See this. So the first key you are adding now, what is that? It will be added now. 103 is the key. What is the value? C is the value. This is the key, this is the value. Then next. Right, space, 1 second. So this is the key, this is the value. Fine. Next, I'm adding 105. So the keys are stored in sorted order. Okay, so see the output first. Just I'm filling the values. I'll do the output for you. Yes, see, it will print all the values. Key value, it will go on printing. Understood? So just I'm printing and toString has been overridden. Where? In map. So it's printing all the values. So but if you see I've stored, means when I'm inserting, I've inserted in this order. But while printing, it was printing in what order? 101, 102, 103, 104 means it is storing in sorted order. So the keys are stored in sorted order. I'm just drawing now how it is actually getting stored. See this. 103. Then what? Next value is getting added. Okay, first element it will add blindly, nothing it will bother. But when you add the second element, okay, what happens? Compare method is invoked. The compare to method. The compare to method is invoked in which one? Class integer. And class integer is implementing what? Comparable, luckily for us. Okay, so it will be calling the compare to method because tree structure always uses what? The comparison logic. And that comparison logic is present in the integer class itself. So I am calling which method now? We are seeing here in map, put. We are using which method? To put the values into the map, I am using put method. So it's abstraction. You just call the method, automatically store in key value as key value now. So 105. So compare method will be called. Is it greater or lesser? greater, so it moves to right side. Think. This is the key, this is the value. So like this, the values will start getting stored now. Understood? 102. Less than what? 103. So it moves to left side. 102 BBB. So what is the key? This one. Okay, so like this it gets stored now. Now next is what? 101. Lesser than this. Okay. 101 value is AAA. So this is the key, this is the value. Then 104, less than 105 now? That's it. So all the 5 elements will be stored as key value pair in the primary memory. Done? Understood how they are getting stored now? Okay. So just understand the concept. Later on we'll see how it is used in applications. Understood? This is the concept. So Java is giving you tremendous support to store what? Only values also, or key and values like this also. Done? So comparative method will be invoked now and it will go on getting sorted. So fine, next. It's not that you have to always use integer only as keys. One more example we'll see now. The next example what I'm showing you is, I'm using what? Strings also as key, double also as values. Anything, but they should be compulsory objects. You can't add primitives here, that's it. Means you can add only objects. And remember, your key should be implementing comparable, or it should have the comparison logic. Now string is also implementing comparable now. Luckily for us, string is also implementing comparable, it will have the comparative method now. So let's see how this program is going to execute now. First see the output, and again I'll draw the diagram for the second one now. Yes. See, I stored in this order. What order did I store? First I put Kumar, Ravi, Amog, Vinay, Balaji. Now how is the order it's getting stored? It's sorting by keys, not. It's not sorting by values. Values are like this. Is it sorting by values? No, it's sorting by keys. So first Amog will come, then Balaji, then Kumar, then Ravi, then Vinay. Like that it goes. So always the keys are stored in tree structure. So if you want the diagram, yes, we'll draw for this also. So first which one? Kumar. Yes, sir? And value is what? 11.11. So like this key value will be stored now. This is key. This is value. Now I will not write KV, you understand now. This is key, this is value. You only go on writing KV everywhere. So then Ravi. Greater than Kumar or lesser than Kumar? Greater. So it will move to right side. So Ravi is the key, value is what? 22.22. Next Amog. It is lesser than Kumar. So it will move to left side. Then Vinay, where it will move? Right side to Ravi. So you know the tree structure, simple. So once you know the data structures, now things become very easier. Balaji is greater to Amog, so it will move to right side. So this is how it is getting stored now. 55.55. So all the keys are actually stored in sorted order for you. It will be using the tree structure. And now if you print, yes, you saw the output already. Now this is the output. Done now? Fine, very simple storage. So here I have commented. See, add key value to the TreeMap, and TreeMap stores keys in sorted order. Understood now? So anything can be a key, anything can be a value, but rule is your key should be having the comparison logic. Yes. So now it is following almost all. TreeMap is using tree structure to store keys. Yes or no? Yes. So let's see. Some R&D will do here. So TreeMap cannot store dissimilar keys. Yes or no? You know behavior. So see, I'll try to add a dissimilar key now. String okay, fine. Now, supposingly, I'll add the third element as customer map dot put of key value I have to put. So I'll put new integer of what? 10 comma value will be okay new double of 99.99. Compile. There's no issue. But during runtime, see what happens. You get the class cast exception. How can an integer be compared with a string? Illogical. So you cannot add dissimilar keys in TreeMap. Dissimilar, only similar type of keys. So now similar type of keys means what key you add first. What type of a key you add first? All the keys should be of the same type next. Understood? Means you can add a string first. Okay, the second key what you add should be of type what now? See the second one what you add now. First one you add anything, it is not bothered. But once you are adding the second one, now it will become bothered. Understood? First one you add string, no problem. It will not call anything. See when you say put of Kumar, directly it will take that and store it. No issue. But when I am calling the second one, now compare to method is called. Till then it was not called. So when the second element is added, the put method internally goes on invoking what? Compare to method. So till then it was not invoking. So that is why when you add, see first element, I will comment everything. So when I am adding the first element, like this you do R&Ds. You clearly understand. Simply don't see the program and get the output. Output everybody will get here. Learn concepts. Understood? So this is how it works. First element. Now the same I'll do for what? Just one extra element I'm adding now. It's of type what? Integer. Now see what happens. Class cast exception. Understood? So first key what you add. After that it is fixed. All the keys should be of same type. Okay. So now see, I'll just add one string now. This one I'll add. Now both are strings now. See it will work. Simple. So the same way here also. If here I am adding, what is the first key I am adding? Integer. Second key should be of type what? Integer only. You try to add one string here. This one. It will not work. Getting it now? So key should be of what? Same type. So first one is an integer here. First one will work. But the second one it will not work. If you want, what you do? Again comment and see. First one is working. See that when you add the second one only, problem starts off. Because when you add the second element, for the second key, which one will be called? Compare to method. The first key will be taken, compare to will be invoked with the next key. Like that it goes on comparing and then storing it in sorted order. Understood now? Okay. Now one more thing. The conventions. See first I showed you only map. In companies now you have to follow conventions. See don't use only map, just say customer map, employee map. For list what we say? Employee list, employee set. So that name itself indicates what is it containing. List of employees, set of employees means, list of employees means duplicates can be there. Set of employees means no duplicates are there. So it will be very clear. Same way here also you should say what? Customer map. Understood? So fine. And this is done. Now one more thing what you have to understand here is I cannot have null key. This is one more concept now. So you cannot have a dissimilar key and null key in what? TreeMap. Obviously null value is not allowed in tree set also, na? How can null be compared with string to sort? You cannot compare null with string to sort. Okay, so obviously here also it will not be applied. When it is not allowing in tree set, same structure it is using here for storing what? Keys. So that's why a null key also will not be allowed here. See this, null pointer exception or something you will get. So if you add a dissimilar key you will get what? Class cast exception. If you add null value you will get what? Null pointer exception. So you should know when you get these exceptions. Clear? Fine. Convention you understood? Okay. So if you got this much, you got the grip of maps now. Understood? That's all. Nothing is more there in maps. Okay, fine. So this is done. Okay, now we'll see the next example. Very interesting now. Let's see how you use the map now. Other more methods we'll see. Yes, there are more methods. You can see is empty, size. So almost all these methods come from where? Map interface. So these are common methods what you'll find in what? Hash map, linked hash map, hash table, properties, everywhere. So just learn it. In one place you have put the effort, now all rest all will become what? Easy. Okay. So now see here. So map, customer map dot is empty, customer map dot size. So before adding elements it will be what? Is empty is true. Okay, and size will be what? 0. I'll add some elements. I already added, you can see the table there. Okay, same one we are referring to. So once I add it, what will be the size? 5. And what is empty will be what? False. Yes. Now very interesting. So I'm showing you how to do the CRUD operations with what? Key value pair. So put will always do what? Inserts the value. Means we are saying how to insert a record, update a record, delete a record, read a record. End of the day when you have values you will do only 4 things, nothing more you will do. Apart from doing CRUD operations. CRUD means what? Creating, reading, updating, deleting. Apart from doing that, next what will you do? Sorting and all that. Okay, and visiting the elements, iteration. So same things we are going to cover here also. Understood? So first we'll see how to do the insert, update, delete and read operation. So put is doing what actually? Insert operation only. Fine. Now how to do the update operation? Use the same key. Automatically it updates the value. So I'm using the same key. Is there a key called as Ravi here? Yes. So see when I, okay, first we'll see the output. To output you see just, then we'll see the other methods. Just focus on the first one. Size tree map is empty before adding values. Customer map dot is empty. True. It is empty. Size is what? 0. After that, I'm adding 5 values now. 1, 2, 3, 4, 5. Now is empty is what? False. After adding it, check. Is empty is false. And how many? What is the size? 5. Okay. Till here if you understood. Now we'll continue with more things, other methods. So using same key, we'll update or replace the value. Understood now? If I use the same key, what happens? It will update. What is the value of Ravi? 22.22. So what will happen now? It will update it. So it will become 99.99. So we'll see all this, don't worry. So from 22.22, I will not erase it off, I will just strike it and write. So it will be overwritten with what? Fine, this is what is happening now. Next, see how you are working with the map. Then next, customer map dot put Praveen comma Praveen. What is the concept here? I am adding different type of value. Till now what values I was adding? Double values. But what is the value I am adding now? String, possible. So dissimilar keys are not allowed, but dissimilar values are allowed. Getting it? So where will Praveen go in now? Lesser to Ravi now. So it will come here now. So what is the key? What is the key? Praveen. What is the value? So the key is kept, okay. So that clearly shows that Praveen is a dissimilar value. This one I am talking. Understood? So this value is string now. Fine, next. I can put null value in a tree map. So dissimilar value is possible. Null value is possible, value. But null key and dissimilar key is not possible. Null key is not possible, dissimilar key is possible. Dissimilar value is possible, dissimilar value is possible and null value is possible. Yes, so where will hello go now? Balaji is there, no? So then, okay. Lesser than k, greater than Amol. So it will come here, huh? Here it will come now. Oh, it will come here. It is greater, no? Yeah, greater, sorry. Then again, means don't bother about the tree structure too much. Okay, just where it will go? Correct, huh? Oh, greater, no, sorry. Yeah. So hello, what is the value? Null. But hello is notice string. Right side of what? I was drawing, then you are telling no. Yeah, because it is greater, it will come to right side. So fine. So this is how the hello is getting stored now. Fine, next. So are you clear with this? So what is the concept you understood here? If I use the same key, it updates. That's one concept. Next concept. But what is the method I am calling for updating? Put only. For updating, which method I am calling? Put only. For inserting also I am calling what? Put only. But difference is, if the key is not there, it will insert. If the key is there, it will overwrite the value. Understood? Next. I can put dissimilar value. I can put null value in the tree map. But yes, you already know this now. I cannot put null key and I cannot put dissimilar key. Yes. So after all this, we'll see the output till here now. Customer map. Till here we'll see the output. You already got executed this. Now see the output. See, these values are stored now. In what order? Ascending order now. Amok, Balaji, Hello, Kumar, Praveen, Ravi, all has been stored. What is the value of Kumar? Okay, I didn't put it print, I think. So after doing all these many operations, I printed it and showed you. Done? Fine, next. Customer map.get means I want the value now. So how will I get the value? Use the key to get the value now. This is what you are doing now. Read operations. Okay, so we are seeing how to do the read operation now. Customer map.get of Kumar. So I say customer map.get of Kumar. What is the value of Kumar here? 11.11. So it is stored. The return type of that is object. You have to typecast it if you want to use it. You have to typecast to integer. Again, integer should be typecasted to int if you want to use it as primitive style. Understood? First you have to typecast to integer, then you have to do unboxing. So you have to do unboxing and use it as primitive int. That you take care. Anyway, the return type of get is what? Object. Now again I am trying to say what? Customer map.get of Ravi. So what is Ravi's value now? It is not 22.2, it is 99.99. Done? So it is 99.99. Then next, customer map.get of Tom. Is Tom present there? So if it is not there, what will you get? Null you will get. And the key is not there, from where it will give the value. So return type will be null now. Yes. Then there are more methods. Contains key. You can use this now. Contains, you know now. Does it contain a key called as Ravi? Yes. Return type is what? Boolean. Does it contain a key called as Rama? No. Return type is Boolean. False. Then next, you can check the value also. Contains value. Okay. Contains value. So we are checking. Contains value is what? What is the value we are checking? Yeah, 33.33. Is it true or false? 33.33 is here now. Who is having? Nobody is having. Here, Amol was having it. Sorry, I wrote it. So, but it will be true or false? Huh? False. We are checking with string style. Tricky, that is the one. So if you check it with the double style, it will be true. Understood? So be careful when you work with contains. Okay, in what style you have put, you have to check it in the same style. Amog is having 33.3 now. Yeah. So fine, I just while writing I had done the mistake. Fine. Then next, if I want to, I can remove. So you saw how to read. Now we are seeing how to delete. Just say remove of Vinay. What gets deleted now? Vinay is deleted. Once Vinay is deleted, next what happens? You can print and see. And you can say map.clear also. Map.clear, what will happen? All the elements will be deleted. Same output you are seeing here. Nothing different. Till now we had seen here. Till here we had seen. Next, after that, yeah, customer map.get of Kumar. Value of Kumar is what? So return type is object now. Value of Kumar is 11.11. What is the value of Ravi? 99.99. What is the value of Tom? Null. Now, does it contain the key Ravi? Yes, key Ravi is present. True. Key Ram is present. False. Then next, does it contain the value 33.33 in double quotes? False. Even though it is there, false. Why? Because we are checking it in string style. But the same 33.33 I have added actually in double. Check it, it will be returning true. Now I will delete Vinay. After deleting Vinay, check. Is there Vinay now? Earlier Vinay was there, see there. But where is Vinay now in the second output? It is not there. And after clearing, there are no elements. You can delete all the records also. So most of these methods what you saw, they are coming from where? Map interface only. So if you understand here, almost all it will be same in other classes also. Clear? Other classes means link dash map, hash map and all that. So work hard here itself so that it becomes easy in those classes now. Hardly have anything to struggle with. Clear? Yes, this is how it works. So you understood this diagram now? So as you see, as you went on adding the keys, the map started growing. First only it was not there. So I added the first key, then I added the second one, then I added the third one, like that it starts growing. It is dynamic. Size is unlimited now. How many ever keys you want to add, how many ever values you want. But if you want to add anything in a map, it should be what? Key and value. Only value you can't add, only key also you cannot add. So when you are adding elements in this map, you should add key and value together you have to add. Done now? Okay, fine. Okay, now my requirement, next requirement now, I want to store the keys in descending order. By default it was storing in what? Ascending order. Means if I give integer it was storing as 101, 102. If I was giving strings it was storing in the ascending order, natural order it say. Whatever the natural thing it is having, means by default what it is having, the compared to logic of written in those classes, it will be taking that, it will be sorting now. Natural order it's called. Fine. But I want to store the keys in descending order. Can you guess now? What will I do? Huh? So for that, first refer to the document. Okay, and you can see that you'll be having one constructor with comparator. That's it. So write on comparator, send it. Automatically you can store the keys in descending order. So simple they are made. So life is so easy in Java. You don't have to worry about anything here. So only you should be good in browsing through the documents. And I believe you are very good in browsing. Yes or no? You are excellent in browsing. I don't have to teach you how to browse. Okay. And as well as you are good in English, means if you are good in these two, coding Java is the easiest. Understood now? Yes, Java I am making so easy for you. See? That dead easy. There is no difficulty only here. Yeah, you can see this constructor now. Comparator it says. You have to pass an argument. See, this till now is using which constructor? The default constructor. So now if I use this constructor, what happens? Finished. Okay, means it will start storing the keys in. It will start using the comparator logic. It will not use the compare to logic present in the element. It will not use the compare to logic present in the element. Instead, it starts looking for the compare logic present in the comparator. That's it. I can go through this example now. Yes, the example would be, it's there in this package. My comparator I am writing, but I am reversing strings I am using here. If you want, you could have used what? See, for this example I am showing you. So till now what was happening? See, this was how it was happening. Here the keys will be stored in what order? Because I am using what? Default constructor. Same thing, but I am having one more map object now. Customer map 2. Okay. So here I am passing the comparator. That's it. So in this customer map 1 it is ascending. In customer map 2 it is descending. Over. So simple, man. Unbelievable it is. Unimaginable, no? What more do you need? Luxury in Java. You can play around. Understood? But the same things you want to do in any other language, what you have to do? From morning to evening, like scientists, you have to work. You're nothing. It's complete abstraction. You don't know how you get the output, but you start getting the output. That simple it is. Understood? Fine. But for understanding all this, you know your effort. You work locked on the basics. That's why you're getting this right now. Understood? So basics of Java is very essential. Fine. Shall we clear this now? Yes. Next, we'll see how to iterate. Iteration is required now. Sorting done. Ascending order, descending order. We saw how to insert, update, delete, all that. Last thing what you are going to do is what now? Visit the elements. More than that, what you will do? So let's see the example now. Okay. So I'll take this example. I'll clear this. Shall I clear this now? This I'll clear? Yes, we'll see how to iterate now. So we have got this one now. And we'll see how to iterate. Yes. So there are some methods in the map interface. So if you know how to iterate in TreeMap, same thing, you will know how to iterate in what? Other maps, hash map, linked hash map and all that. So understand in one place. So iterate, see now. Here the thing is, you are having key value, key value. Now how will you iterate? So they are giving you three options. One, you can get a collection of only keys. Only keys you can get. Two, you can get a collection of what? Only values. Or three, you can get a collection of only key value. So first I'll show you how to get the collection of only keys. To get a collection of only keys, just call the method keySet, map.keySet. The return type is set. So means when you call this method, what will that method do is, see which method you are calling? KeySet method. So KeySet method, what it will do? It will give you collection of keys. That's it. Nothing else. And what are the keys? And it will give it in ascending order. 101, 102, 103, 104, 105. So all the keys it will take and give this set now. Okay. And the cursor, you know, the KeySet method is doing this now. Who is doing this? KeySet method. Yes, is caps. It gives you collection of keys. And the cursor is pointing to before first. What am I doing? Has next. Next. Has next will check whether there is an element or not. And then next will move the cursor. Return type is object. Typecast it to integer if you want to use. And I'll just print it. Just see this. So you'll get only keys now. I got this now. I'm just doing only print. See, I'm printing only the keys. Done. But in what? Ascending order. All the keys you're getting in ascending order. Fine. Then next. If I want, see this very tricky here, little interesting. If I want, I can only use the keys, or I can use the key to get the value also. How? Map.get of k. Till now you are saying get now. Same thing I am doing. I got the key here now. And you can use what? Both key and value. If you want to use only the key, or you can, if you have the key, you know what to do now. You can get the value also. That way also you can work now. Anyway, because I am printing it twice, it's happening. Or you can comment one output. Which one? This one you comment. So now what happens? You will get only, yeah, both will get now, key value. Done? So but what is that you understood now? KeySet will give you a collection of only keys. That's it. Okay. So then next. So yes, we'll see how to iterate only through values now. Yes, the method what you are going to call is what? If you want collection of values, what will you do? See, this was collection of keys. And your iterator was referring to before first. Now you get collection of values. Okay. Again, according to the key only we will be getting the value. Understood? But here for A I have taken 101 I have taken A. Now don't think you will get values in alphabetical order. Understood? How your keys are there, based on that you will start getting the values. But since I am using A, B, C, D, I will get it in A, B, C, D order now. So I am getting only what now? Values. And here the method is called as, what is the method? Values. See, map.keySet. Map.values. Where's the cursor again? Iterator before first. So I'm getting only values this time. Fine. Map.values, return type is collection. Which one? Super interface. From there I'll call what? Iterator. This is how you work here. You have to understand that and work. Call the methods. Understood? But the okay. So now when I print this, You get only values now. But don't think it is alphabetical. Okay, how your keys are stored, based on that order it will be giving you the values. Done? Because I am storing A, B, C, D, you are getting it in that order. For 101, what is the key I am storing? A value I am storing? A. For 102, what is the value I am storing? B. That's why I am getting it like this. Fine. Clear? Yes, can you notice a slight difference between key set and the values? Yeah, in key set, directly you will be getting what? Set. But for values you will be getting collection. Doesn't matter. Can you guess why? Here why you get set and here why you get collection? Because keys should not have duplicates, no? So that's why it is bringing what? Set. Here it might be duplicates, no? Values might be duplicate, remember that. Understood? You can have duplicate values also here. Okay. I didn't show you, but you can add one duplicate value and see. Value you can add. Understood? So that's why you get the return type as collection. That's it. Very simple. Okay. Yes. Done? Done with keys, iterating through keys, iterating through values. Fine. Next. Very interesting iteration. See, SOP TreeMap will print all the values. Till now you are seeing what? In the first example, what did I do? SOP TreeMap, what it will do? But our intention is not to print, our intention is to access one by one, use it. So let's see how do you do it now. So either, that's what, visiting the elements. So you can do it like this also. What is the method name I am calling? Entry set. In entry set what happens is, you will have key also will be there, value also will be there. Like this, both combined you'll have. And where is the cursor? Before. So you'll have collection of what? Before first, here also. Iterate will be before first. You'll have collection of key and value. I'm putting slash and writing here. Collection of key and value, both you'll have. And this is map dot which method? Entry set method. Done? You'll have both. So is the cursor here. Yes. Now very interesting. And I say itr dot next. Return type is object. Okay, but I'm typecasting it to what? Map dot entry. Now if you ask me what is map dot entry, so it is an object which contains both key and value. Map dot entry is an object which contains both key and value. Means in that map dot entry object now you'll have this two, both of them. Key also you'll have, value also you'll have. And but what is map dot entry now? One more question you'll have. Entry is an inner class. You know inner classes now? So map dot entry. Entry is an inner class of what? Map. So you are seeing the usage of inner classes here. Don't worry, you don't bother about that now. Okay, so return type is map dot entry, typecast it, ME. So in map dot entry there is a method called as what? Get key. So it will give only the key now. What is that? 101. So I am not using anything here. See here. I'm not using 0, 1, nothing. Just I am saying get key because your cursor is in the first place. It will give only the key. Then it will print what? Get value also you can get, but value is of type string. I am typecasting. You have to typecast the key also, you have to typecast the value also. Then it moves to the next element, has next. Again, return type is what? Map dot entry. Means one more object you will get of type what? Map dot entry. Again you will have what? Key and value. So again first I will get what? Key. Then I will get value. Again iterates. Again you will get one more object. That object will have what? Key and value. So what is map dot entry? It is an object which has both key and value like this. Simple. So you can iterate like this and use the value. So three types of iteration I have given you. Only through iterating through keys, or only iterating through values, or only iterating through key and value. That's your wish. How you want to iterate? Iterate and access the values. Clear? So I'll show you now. Yes, but notice here what is happening. To get the value, I am not using any key. Directly I am saying what? get value. I'm not using the key only. Earlier to get the value, what you are saying? Get and you are passing the key. But I'm not saying anything now. Just I'm saying get value. That's it. Clear? So this is how we can access all the elements. Clear? So understood all these iterations? Brilliant, no? You can store the values as what? Key and value like this. Yeah? Any questions you are having in this iteration? Understand one structure in a tree map, hash map, dead is the same concept. Only keys will be stored where? In hash table, that's all. Nothing big difference. Understood? So one concept you understand, you'll get the grip of everything. And one more brilliant feature is, you have a standard way to work with all the maps now. That is more brilliant of Java. Only methods will be same, data structure will be different. One uniform way of working. So work with this, so that tomorrow or in the next class, hash map becomes very easy for you. Hash map, linked hash map, all will become very easy for you. Done? Okay. So shall I clear this now? Shall I clear this? Any questions if you are having, ask? No? Or effort, you have to put effort and you have to debug your own doubts now. You should have that ability. Clear? I'm going to clear this now. So which iteration you want, you decide. Collection of keys means you'll call key set. Collection of values, map.values, both key value, map.entry set. Definite interview question. Definite 100% interview question. Clear? So we'll see some notes for TreeMap now. Now before that, you can see the folder structure what I use is the project is 9th project. Clear? And all the examples are kept in the same project. First 3 examples are in com.cluster package. The next example, iteration means the sorting is there in other package. And the iteration I have kept it in this package. Clear? Some few examples are there. That's the one which I have opened. Can go through that. Okay, arranged. So organize your files properly so that tomorrow also it will be very helpful for you to refer when you are working in industries also. Okay, lastly some notes. This one I covered, this notes. Map is used to store what? Yes, if you want you can reuse it and check this. It's a part of collections framework we say. I had discussed at the beginning of the class. A map is an object which stores what? Key value pair. We had discussed this earlier. Okay. Now you need a key and a value to store in map. Understood the point? Yes. Both key and value are what? Objects. Clear? The next point. Given a key you can find its value. Clear? The keys must be unique. Yes or no? You cannot have duplicate keys here. So but you can have duplicate values. Some maps allow null keys and null values. TreeMap is not allowing null key, but TreeMap is allowing you null value. So that's what I have written. Some maps, okay, means hash map and allow you null keys. We'll see that next class. Okay, others cannot. There are many different implementations of the map. This is generally what we discussed about what is map. Now to be very specific, we'll move to TreeMap, the implementation. Yes, this is TreeMap for you. Simple notes, few points. TreeMap is implementing what? Sorted map. TreeMap can store what? Key value pairs. TreeMap uses tree data structure to store the keys. The keys are stored in sorted order. Only similar type of keys are allowed. Different type of values are allowed. Duplicate keys are not allowed, but duplicate values are allowed. Null keys are not allowed, but null values are allowed. The map is not synchronized. TreeMap is not synchronized. These are some few points now about TreeMap. Nothing more is there. So everything understood TreeMap. Now, as we always discuss, where exactly is TreeMap used in real life or applications? We should understand now where it is exactly used in applications now. So that also we'll discuss. Supposing I am having a table. Think practically now. Always when you see some concept, see whatever I am teaching you Java, one is I am teaching you from Java concept, other I am teaching you is from application point of view, real usage point of view. So I am teaching you Java from 2 dimensions or more dimensions. Okay, so understand Java properly. It will be very helpful for you in the industry. So I'll have employee ID. This is employee ID. Then I'll have what? Name. Then I'll have what? Phone. Then I can have what? Email. Yeah, I'll fill some values now. 101, 102, 103, 104, 105. So I'll go with names. Ravi. Kumar. Vinay. Amog. Fine. Now there can be 2 employees with same name, no? Getting this idea? Get the idea first practically. Okay. Phone number. Okay. They can have different phones. That is irrespective now. But not 2 employees will have same email. Yes or no? So they can have. See here I'll have Ravi at Gmail. Or I think you should fill everything in caps only. Ravi at Gmail. Kumar at, or they can have their company's email ID at cluster, something like that. Cluster, we'll take cluster only. Cluster.com. Ravi at the rate of cluster.com. Vinay at the rate of cluster.com. Amog at the rate of Amog cluster.com. Now if there is one more Ravi who wants to become a member, definitely they'll add some initials to him. So it will be something like Ravi K, but he cannot have the same email ID. Ravi K at the rate of cluster.com. So this is how your table is now. Yes. So you want to fetch these values from the secondary memory into primary memory now. Yes or no? So see, I'll just give you a big, just draw it big so that you'll understand. So this is your application. And here there will be some request to your application, and your application will connect to database, fetches the values now. So there is some requirement now. You want to store the values in the form of key value pair. So now you have the option. Remember in TreeMap, in TreeMap you cannot store duplicate keys now. Okay. So which column to make the key you decide. Name, can it be used as a key? No, because they can be duplicates. And if it is if you are using name as key, what will happen now? The value will be overwritten now. If I say put, what happens? First Ravi will be inserted, next Ravi will be overwriting the value of 111 and replaces it with 555. So that will be the problem. So see to that your column, whichever column you pick now is having either, it means it should have unique values. So better you pick the column whichever is unique or primary key. So any primary key column can be used as key, or any unique. See, I can make phone number as unique now, constraint. Email also I can make unique now. So always pick the column which is having unique constraint or primary key. Primary key is also by default what? Unique only. Now I can fill. Okay, so you can use a combination of what now? ID with name, or phone with name, or email with name. That is your wish now. So anything you can make as the key, anything you can make as a value. ID will be what? Integer. Name will be what? String. So let's see this now. So I'll go with what? Map dot put of ID comma name. This is one way you can go. ID and name, one combination. Or other one means ID is what now? Integer actually. Map dot put of new integer of ID. Sorry. But see, I'm hard coding here. Just Understand? Later on it will become dynamic. ID and name will be what? Strings. Like this I can go. This is one option. Other option would be what? It's your wish now. Whichever values you want, you pull out now. I use phone number and name. That also is possible. So I'll go with, generally phone numbers will be stored in what? Strings only. Then next one is what? Name. So like this you can store. Or you can go with what? Email and name also. Like that any two columns you can pick. Key value you can go on storing. That's your wish. So I'll just show you. See, third one is map.put email and name. Something like this. Understood? So I'll take the first option and show you how the values will be stored now. Understood? Supposingly I am adding ID and name. So this is how it will be done now. 101. Understood? Or I'll go with 101 is all will go into what? Right side only, the tree. Okay. So yes, just understand. This is 101. Name is Ravi. So key is what? 101. Next is 102. Kumar. Then next is what? Vinay. Like this. Then next is what? 104. Amog. And lastly 105 is one more Ravi. So like this you can store. Key value, key value. Understood? Or you can go with the second combination, phone and what? Or I'll take email and name. Email and name. Third combination I'll take. So first one is what? Ravi is the key. Phone, email is what? Ravi at the rate of cluster. Email is key, sorry. Ravi at the rate of cluster.com. Name is Ravi. So this is one more now. One more tree we are creating. This is the first one what you saw. This is the third one I am doing. Email and phone. Okay, then next one is Kumar. So lesser to means sorry. Kumar at the rate of. So I'll go lesser this side. Kumar at the rate of cluster.com. Value is what? Kumar. Next is Vinay. So Vinay is greater to Ravi now. Vinay at the rate of cluster. So Vinay at the rate of cluster slash Vinay. So key value like this you can go on storing. I just showed you for 3. This was the third option what you are seeing. Are you clear now? This is a different one, this is a different one. Don't get confused. This is about phone and ID and name. This is about email and name. So whichever one you want you can make as key, whichever one you want you can make it as value. Just 4 columns I have written. Like this you'll have so many columns in your database. But ideal suggestion is always make unique columns as key or primary columns as key, so that you'll never get the duplicate keys practically. Understood? And you'll never lose any value also. It will allow, TreeMap will store, but it will overwrite the value, you'll lose the value. Understood? That is the problem. I could have made name also as what? Key. Nothing problem. But you'll be losing which value? By the time you start using it, you'll be losing the 111 value. Understood? So because you'll be getting always 555, because you'll be saying put. So that automatically put, if you use the same key, it overwrites the value. Simple as that. Yeah, practical usage. So this is how Java gives tremendous support for writing your applications. Tremendous support. Where other languages really fail. Done? Okay, practice this a lot, because next classes we'll be dealing with hash map, linked hash map and all. Same concept, only the data structure will change. The data structure of the which one? The way the keys will be stored now. The keys will be stored in just hash table structure. That's it. Understood? That's it.